Hi, ACST1052 students. This is Doug Fletcher with the first in a short series of videos on dynamic arrays in Excel. Now, dynamic arrays emerged in Excel in the 2021 release and are now standard throughout the Microsoft Office 365 releases. In other words, it's pretty much universal in corporate and university computing environments. Very, very widely available in your future workplaces, quite apart from at Macquarie University. Dynamic arrays essentially were a rewriting of the inner core of Excel so that really everything is an array unless you specifically tell Excel that you don't want it to be an array. So we're going to have a little look at a spreadsheet exercise and then use that to indicate why this is particularly useful and why it's a really good idea for you to become familiar with it. So I'm going to share my screen so you can see my Excel workbook. And what I'm going to do here is run through creating a little table of financial functions. Now we have here an accumulation function, 1 plus I to the power of n, a discount function, 1 plus I to the negative n, present value of an annuity. You'll see I don't have the angle bracket notation here, and also the accumulated future value of an annuity, Sn. At the moment, this is set to be an interest rate of 6%, and of course we would want the whole table to reflect that 6% or whatever value we change it to. And I've also got a maximum term here that'll indicate how many rows we want in the table. Now, if we were doing this in the way that Excel used to be done, then we would, having started from the top row where we've got the correct values in for a period of n equals 1, then we'd want to create more rows in the table. And we do this by creating a formula here to say we want that cell plus 1, and then if we copied that down, we would get more rows like so. And here we would want to take 1 plus I, so the B1 gives us the interest rate, but if we're going to copy that down, we would want to make that a fixed reference, so we put the dollar signs in and we raise that to the power of whatever number appears in the cell immediately to the left, in this case B5. So if we hit enter there and then we can copy that down, the fixed address always refers to the interest rate of 6%, so we get 1.06, then we get 1.06 squared, 1.06 cubed, and so on. And if we kept going to however many rows, in this case 10 rows, and did that for the other 3 columns, then we would get 10 rows by 5 columns, that's 50 different formulae constructing this table. Now, consider if we were doing a complex financial model or a simulation, we could possibly end up using the traditional Excel method, we could possibly end up with thousands of formulae. And if there's an error or something crops up, it becomes very difficult to check unless you're extremely organized. The thing about arrays is that it lets us control this whole exercise using 5 formulae, which we will put in the top row of figures here. So we have far fewer formulae when we use dynamic arrays in Excel. The approach is also much more easily scalable. As soon as we want to change the size of the table, we will simply say, change this maximum term number, and the dynamic arrays will respond to that. We can have 15 rows, we can have 50 rows, we can have 3 rows just by changing that one number. I mentioned before, because there's far fewer formulae, it's easier to check what is going on. And lastly, especially for people who are heading towards actuarial work, actuaries are dealing with vectors and arrays of figures all the time in doing projections of cash flows into the future. We're discounting those or accumulating it with a certain interest rate, and being able to apply discount factors or accumulation factors to a whole array of cash flows is extremely useful. And to do that with as few commands as possible and reducing errors as far as possible is very, very valuable. So in short, if you become familiar and expert with this feature of Excel, dynamic arrays, this will pay off in a really big way. Okay, so how does this work? Let's have a look at how we do this. So rather than doing it with 50 formulae, we're going to do it with 5. Now, the first thing that we need is a list of integers in this first column under the n. And so we need a way to create a sequence, and Excel now has a sequence function, and it wants us to tell it what's the shape that we're going to put it into, how many rows and columns, what's the start value for the sequence, and what's the step value, how much will the sequence increase with each step. So we're going to want the same number of rows as the maximum term. So that'll be 10 rows. Now, we don't need to worry about fixed or relative addressing here, because we're only going to use this formula once. So we don't even need to think about copying down. So we're not really fussed about using fixed addressing here. We only want one column, and the default start value is 1, which is also the default step value. So we can stop right there, and we will get a list of integers 1 to 10. Okay, that's really good. And this lets us indicate one of the features of the dynamic arrays. Now, you'll notice now that that list of integers 1 to 10 is highlighted. We've got this faint blue line outlining it, and then there's a pretty looking shadow around that. So anywhere within here, we can see we're in this list, and all these numbers come from the cell at the top left. Or since we've only got one column for this, it's at the cell at the top. And the other thing is, if I go down below that top cell, the formula in the formula bar up here, the formula goes to grey. I can't edit that in that cell. So if I press F2 to edit the contents, there's nothing there to edit. And that's because there really isn't any formula there. There's nothing there except numbers that are generated by the formula at the top left. And one of the things that often happens that when you're using dynamic arrays is you may accidentally put something in one of these cells that are part of what we call the spill range. So the spill range is the whole range of numbers produced by this formula at the top left. So if we put something in here, doesn't matter what it is, then that's going to interrupt that range. And so you get the spill error. And the spill error is simply saying, I was supposed to have control of that cell, but something's in the way, so I can't write what I was going to write. That's the spill error. Now, this spill error is simply in this particular column caused by the letter that I've typed in there. And these other spill errors are just echoing the first one, because each of these columns refers to the first column. So as soon as we remove this character here, that removes the obstacle in the way of the that formula spilling into those cells, and that removes the error. So when you're first playing around with dynamic arrays, you're going to see the spill error fairly frequently, and that's all it means. So you just need to get used to that. Okay, so that's how we get a sequence of integers that dynamically responds to this maximum term. If we change that to 12, we would then get 12 in that spill range. If we go 15, we get 15, and so on. Now, let's look at the first accumulation column here. So at the moment, we have 1 plus I to the power of n, referring to the first column. Now, as I said, we're only going to use each formula once, so the idea of fixed addressing is just not relevant anymore. So I'm taking the dollar signs out there. We're only going to refer to that interest rate, but for B5, we don't want to refer just to that, just to that one cell. We want to refer to the whole spill range, and then the formula will recalculate for every cell for every duration. And the way we say grab the whole spill range that starts at that cell is to put in the hash character. And as soon as we do that, Excel changes the highlighted selection from that top left cell to the whole spill range. And so now when we hit enter, that's going to give us a calculation that does that work for every value of n that is highlighted. So there we have all our 1 plus I to the power of n factors, all controlled from this one formula. All right, and once again, if anything gets in the way, then you'll have a spill problem. It just works exactly like the first one did, and it responds to the first one, the first column, the n column, because it's referring to that in its formula there. And we're going to do exactly the same thing for each of these. So here we're doing 1 plus the interest rate, this time to the power of negative the duration, negative n. And so if we put the hash key in here, the hash character in there, then we'll achieve the result that we need. Equivalently, we could have done this as simply the inverse. Sorry, I'm putting that in the wrong place. Let's go back to the top row. We could have done this as the inverse of the figure in column C, the inverse of the accumulation function. Again, if we hit the put the hash character in there, then that'll work for the whole column. Okay, similarly for each of these. Now, for these annuity functions, I've used, rather than recalculating the formula from scratch, I've taken, for the present value, I've taken 1 minus the discount function and then divide by the interest rate. So all we need to do is make sure that the discount function refers to the whole column, and then we will get our annuity values. Similarly, for the accumulation value here, if we take the accumulation function, subtract 1, divide by the interest rate, that will give us our accumulation function for the annuity. If we put the hash in there, it will refer to the entire dynamic array. And then we have our financial functions table. And if we change the table size, that will respond dynamically to whatever we want it to be. Now you'll notice the formatting here is not quite consistent. So like this number here has 7 decimals. Some other numbers have 6 decimals. That's just a matter of what Excel is happy to fit in there. You can control the formatting in a dynamic way with a bit of mucking around, but we're not going to go into that much detail. So this gives you a little glimpse at how to use dynamic arrays. You can set up a dynamic array. You can refer to a dynamic array by using the hash character after a cell name. And you can use this to control entire tables of values from a single row of functions at the, or formulae at the in the top row. Now we'll return to some other aspects of constructing tables. We'll also do some work on the new data matching tools that come with the dynamic arrays, but that's for a future video. Bye for now.